the thing is, by 1 over square root of n?
Yeah, n over n 3/2.
That's not
1 over n to the 1/2, which is square root of n. Wait, either way though, doesn't that say that?
No, but this will prove 0 though.
What does it look like?
It'll be ln n over n.
For those just joining us, they are working on these two problems in the back of their workspace, trying to see if in their groups they can figure it out.
Hi, Baba.
That's 0.
Baba, I can't figure it out. Can you help me?
Well, that means that bottom one's greater than.
I'm trying.
That means the bottom one's greater.
Is ln of n over n.
That means the bottom one's infinity. No, 0. If you 0.
No, ln to infinity.
No, special sequences is 0. Well, that means the bottom one wins it.
Alright, what have we compared it to so far? Are we doing direct or limit?
The bottom one is bigger.
Oh, yeah.
Yeah, the bottom one is bigger.
This is the hardest section we've had this D, I will say that.
And then 1/2 diverges.
I thought it was really easy.
No, that's what
doing
I'm
with this. This is hard. I hope it was easy. This is bigger.
Alright, still thinking? No one's been able to make a conclusion yet?
No, diverge though. It won't help us though.
I mean, I'm going with the first one.
Gabby, put up your hair.
What?
So you guys probably tried 1 over n to the 3/2, right?
Yeah.
Okay, but what happened when you found the limit?
Well, this girl is smaller.
It equals infinity, and the problem is 1 over n to the 3/2 converges. So if I have, infinity as my limit, that means that the bottom is smaller, and if the smaller converges, do I know anything?
No.
So the infinite limit for limit comparison, I need convergent. No, I need divergent, I apologize. The infinite limit, I need divergent. Now, A, if that doesn't pop into your brain, either you need to memorize it forever, the test, the endeavor, really, 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 really well, or work on your understanding, right? So the limit equaling infinity, remember, the top wins, the bottom is smaller, and 1 over n to the 3/2 converges. So, no method. You guys all struggled with that. So what else did you decide to compare it to?
N over n to the 3/2.
N over n to the 3/2? I would do something similar. I would have compared it to 1 over n to the 1/2.
X squared, right? Then you. Oh.
Well, I would have done probably n to the 1/2 next because it's divergent. Now pause. If you did compare to 1 over n to the 1/2, or even 1 over n, when you multiply that up, there's still some n left below, right? Yeah, okay. So still some n left below. Who's going to have the stronger growth, ln or the n?
Yeah.
The n. So the limit's going to be 0. Yay! But n to the 1/2, and n to the 1, and n to any of that is divergent.
Yeah.
Well, great. Now I have the limit equal to 0 and a divergent one, which once again, I know nothing. So, did anybody think of comparing it to 1 over n to the 5/4?
5/4. Whoa, Miss T.
No?
I thought
Well, here's the problem. Pause. Would n squared help at all? 1 over n to the 3/2 was convergent with an infinite limit. 1 over n squared is convergent with an infinite limit. Why am I saying,
Because you'll have X.
guys, hold on.
This is like killing me.
Yes, I'm coughing because I have to strain my voice so loud every day. So if you guys wouldn't mind, let's just focus, yeah? Give me a second. I want you to ponder the question without answering out loud for a moment. Ask me, why would I say, as I'm trying to write on my smartboard that's only half working because the tray decided to poop out today, the new tray that they put in actually, compared to the infinite series, 1 to infinity, 1 over n to the 5/4. Okay, who has an answer? Or just an idea, why would I compare it to 1 over n to the 5/4? No. So what I was noticing is we tried to compare it to 1 over n or 1 over n to the 1/2 to a divergent. It didn't seem to be working. We tried to compare to 1 over n to the 3/2, a convergent, and it was too big. So why not choose something in between 3/2 and 1? So what's something in between? I chose 5/4. What else could we have chosen?
8/7.
Sure. 12/11. Like we could have chosen any of those, right? Because when we go ahead and take a limit, we would have ln of n over n to the 3/2 times n to the 5/4 all over 1. Question, who still wins? The bottom. Why? Because these would reduce, I would still have an n to a power in the denominator, and haven't we learned when comparing degrees, n to any power, as long as it's not negative, will be stronger than ln? We could do L'Hopital's, a quick derivative, would show us everything except the bottom half. So therefore I can say this limit is 0, and what's different about this equaling 0 than the 1 over n, 1 over n to the half, 1 over, this guy converges. So limit equals 0 with a conversion, I'm done. Basic. Now I need to say, since the limit equals 0 and the series from n equals 1 to infinity of 1 over n to the 5/4 converges by, p series, p is greater than 1. Then, my original series converges as well by the limit comparison. So it was tricky, and it was tricky on purpose. It was tricky so I could show you, hey, if you're choosing convergent ones that are too big or divergent ones that are too small, try to choose something in between. Does that make sense? Choose a power that's in between. You guys might not have gotten down to number 5, but let's peek at number 5. Let's peek at number 5. Okay, man. If you were like, man, we're in section 9.4. Limit comparison is what we ended with yesterday, and didn't we leave off a couple examples yesterday? So maybe she just took those couple examples and has us playing with them now. Anyway, you might have figured out, or at least thought of, I need to do that limit comparison test again.
Could you go up a little?
So maybe you would think we need to do the limit comparison test again. And you're looking at that, well, n over n cubed, I could think of that as 1 over n squared, but that 2 to the n, man, that's strong. Wait, 2 to the n, man, that's strong. Don't use limit comparison test.
No.
What should you use?
Regular comparison test.
Peace things.
The term. Nth term test.
Why?
Because if the top bigger, it will never bigger, it won't be
The
0.
top wins. Why even do a comparison test? If the top wins, the nth term test is
Here, what?
All the options.
well, at least you kind of know the options.
I'll make those on this side. I put all the options and put X's through the next one.
This was so easy until we got that.
So.
Kyle, this was a lot simpler than we were thinking.
No, why you
Oh.
think
But that,
it now?
that's what like a last resort also.
Oh no, remember that's our first one.
Oh, good job.
Now, it's our first one in that if we get a limit that's anything other than 0, we're done. But it needs to be one that you are very, very cautious with, because if the limit equals 0, we know nothing. So as long as you know when it's good and when it's not good. This, it was great. Look at that. Look how short that was. Nice and easy. And the comparison test would not have been, well, I mean, I guess we could have compared it to 1 over n squared and we would have gotten a limit. Nope, that was 1 over n. Yeah, we could have compared it to 1 over n. The top would have won, limit would have been infinity. We had divergent, but I don't know if you guys would have thought of that. Jason Johnson is gone. He has a hole.
What?
So was Brendan's piano. I was like, oh, Brendan's gone. He's the only one, right? Okay.
I never heard the only one.
You're all focused on
I
that.
said Jason in my head.
Ha! Hi, Jason.
I heard you guys say
Love you, Jason.
All right, cool kids. I have a quick question.
Hi, Jason.
My twin is gone.
How was this guy?
What?
How was this guy? Wasn't he homework up?
Yeah.
I didn't.
I don't know.
Kyle's the one that.
It was
Wasn't
easy.
what I told you to do.
Oh, wait, no, I think I did.
How was he?
I think I
It was
did.
easy. You told me how to do it.
Just replace it with 1 over n plus 1.
Yeah, 1 over n plus 1.
That's what I did.
Except you have to change the bounds.
Yeah.
You couldn't just say, hey, let's direct comparison let's compare it to 1 over n plus 1. If you did not say for n greater than or equal to 3, or for n greater than 2, technically your explanation is illegal. Why? Direct comparison?
It's the bottom, it's actually losing that point.
Every term has to be, for the direct comparison, every term of the bigger has to be greater than the smaller when doing the infinite series comparison test. And the problem is ln of 2 and then ln of 3. And when you're comparing to 1, ln of 2 is less than 1. Because it's pause. ln doesn't hit 1 until e, 2.71828. So technically you would have had to think about this series as ln of 2, all over 2 plus 1 is 3 plus, this is what you wanted to do. Does that make sense, guys? And then all of a sudden if you said, hey, cool, I'm testing for the convergence divergence of that guy, then you can say, oh yeah, so for that guy, for n greater than or equal to 3, or even if you just wrote that and then you used it, you could say, yeah, that guy, from n equals 3 to infinity, what ends up happening? Converges or diverges? Diverges. So therefore, a divergent plus a constant is still going to be divergent. So we don't have to say that this messes us up at all. Just to be legal, we have to start at 3. Then we can say, yeah, let's go ahead and directly compare to... I would have just done 1 over n. You guys see 1 over n plus 1?
I mean, it comes up to the same thing. It's just ln of
You do n plus 1, you can do like what, the integral test? You do the integral test.
Yeah, I did the same, so it's the most interesting.
Yeah. So what do you do 1 over n plus 1 at the integral test, or what do you do 1 over n? 1 over n is a little trickier because you have the ln that's higher, and then you have the denominator that's higher as well, which would make it lower. Anyway, so I would understand. It'd probably be safer to compare to 1 over n plus 1. It'd be safer. Alright, cool kids. There was one other dilemma with homework, right?
71.
Yeah, how about section 9.3?
I did 17 instead.
Well that was created. 71.
I thought you missed that.
Oh, we didn't have to do
I
that.
had 9. Well, you couldn't do it because, Corey could have because he was looking at the book. However, what was number 17? I don't think I meant 17.
17 wasn't really good question.
Oh, that would have been a
It
nice
wasn't
one. though.
hard.
That would have been a nice one to practice. 71's a lot easier. Oh well. For those of you guys that didn't do it, do you want to see the easier one? 17 is a really good one. I'll probably change that for next year. But anyway, number 71. Just says determine the convergence or divergence. P.S. You have to get this in your homework because it's not on the handout online. So here's 71. Directions are determine the convergence or divergence of the following. And the problem is the sum n equals 1 to infinity of 1 over 3n plus minus 2. Struggle. Using whatever test you want. Oh, nth term test! We know nothing.
Integral.
Geometric series, nope. Integral test would probably be the best.
Nope.
Because of the minus 2. We could compare to something that would be a p series. We could try to compare to 1 over 3 to the n. Yeah. But this is technically section 9.3 series. But you're allowed to do whatever you want, so. You guys like the limit comparison test? Whichever one's easier.
Why not just do it?
direct.
You could do integral.
Why can't you do direct?
Hey, let's not forget.
I feel like when you start learning more stuff, you start forgetting people stuff.
Okay. So if you were to do the integral test, yes, limit comparison is like the same one. We could go ahead and say, since, integral test, what needs to be true?
Positive, continuous, and decreasing.
Positive and decreasing.
Base of n is equal to f of x
Yeah.
is it always positive for
Yeah.
n 1 or higher?
Yeah.
Yeah. So positive check. Is it continuous for n or higher? Sorry, 1 or higher? Because the 0 is at 2/3, right? Is it decreasing?
Yes.
Because ultimately it's just one of these guys, right?
Yeah.
Who's been transformed a little bit. So yeah, he's decreasing. And the integral, limit as b goes to infinity, of 1 to b of 1 over 3x minus 2 dx. Did you guys get 1/3? ln of limit as b goes to infinity, 3b minus 2 minus ln of 3 times 1 minus 2. Does that work?
Yeah.
Yep.
Infinity.
I would do limit comparison of 1 over 3 times n, because then the limit is 1 and it's high. I would compare to 1 over 3 times n.
Wait, but is 1 over 3n bigger or smaller? It's bigger, right?
Oh, they're the direct limit. Because 1 over 3 to the n, you would multiply 3n over 3n.
But
No,
over
this is for
time.
like p series. If you want to do like.
No, the thing is, if you do limit anyways, if one
Wait,
diverges, the
Do
other
you limit
diverges.
comparison?
Do limit comparison, and then 1 over 3n diverges by p series. That's what I thought.
Okay.
Because it's n, p equals 1.
Would you need to do the limit to do?
You don't have to.
Can't you?
It's
Well, you can't do p series as is, because there's a minus 2.
Yeah, but once you compare it to 1 over 3n, would you need the limit comparison? Or just
Yeah, you guys were struggling with the greater or less than thing. I was saying you wouldn't even have to think about the greater or less than thing if you just did limit comparison, because 3n over 3n, the limit's 1. What 1 does, the other does.
Okay.
So I'm just saying, if you don't like the bigger, smaller thing,
Yeah.
just do limit
But
comparison.
what would be the answer for
It'd be divergence, because
that?
1
No,
over
no, not
3
diverges. Is 1 over 3n smaller or bigger? It's smaller.
It's
bigger.
bigger,
Right?
because this denominator is smaller.
Okay.
So the struggle is direct comparison.
But it doesn't matter if it's
You
bigger
have to
than
choose
0.
something else.
Whether it's bigger or bigger.
Looking at the integral test though, we end up getting
Infinity.
infinity,
Yeah.
right?
Yeah.
So you get infinity, then the series diverges as well. Is that okay? Thanks.
I'm sure it's 6
Alright, you guys got it?
Mm-hmm.
Okay, I apologize, that was number 71. It is on the video if you weren't quite ready to get that 71. It is on the video if you can get it. You can grab down the problem or mental snapshot, put it at the top of your homework problems. But we need to go to section 9.5 and start it. Guys, look at the backboard, 9.5. I want you guys to think before you even turn the page, what's different in 9.5?
It's due Tuesday.
Alternating.
Like that board.
What's so different about alternating?
Oh, never mind.
Oh wait, is
Because you alternate back and forth and back and forth and back and forth. What?
Later one?
Guys in the back, you're missing out on the cool conversation that we're having right now. And how do you look at 9.5's title? Read alternating series test and think, alternator, car? Anyway, alternating, kind of similar. Alternating, what could be happening?
The ratio.
Back and forth, positive, negative.
Positive, negative.
Yeah, good job.
Like, many things could be alternating. Oh, thank you. Many things could be alternating, but what is alternating is the sign. Do we have any test that allows it to go positive, negative, positive, negative?
No.
I don't think so. Not unless nth term test, the limit is anything other than 0. We can do that with alternating, right? You did that with sequences of terms. We had alternating ones you had to be careful of. But alternating. Remember we had some that started off negative and went positive. We had to split up the bounds. But a lot of the tests so far have been like we need to have only positive terms. All right, we're ready to go now? Kiddos, in section 9.3, whoever's bag just fell, probably Justin's. Looks like this. In section 9.3, did you guys have any evens? I didn't even think to
yeah, we
ask.
did.
Wait,
Yeah, we did.
All right, and on Monday we'll have to go over the evens, okay? I apologize. That was my
Wait,
bad.
you mean there from 4?
Oh,
Yeah,
yeah. But we had evens in 9.4.
Yeah, we did.
First thing Monday, when you guys come in, you're going to grade them in your groups together and see if you agree or disagree. And then we'll go over discrepancies. Sound
Yeah,
good?
Bubba. High five.
All right, so 9.4 evens, grade on Monday. and 9, 5, alternating, signs alternating.
The n, right? Or n.
N minus 1. It's n equals 1, I apologize, that little line. I'll try to get the smallest line possible to see if I can get it to match up-ish.
Was it the first one, second? Not like.
There's an A and there's a, oh, what did change?
I think it's just saying the series and if the series converges. Never mind. Shouldn't
That
it
looks
be B in
neat.
the end?
Yeah, wouldn't it be B?
Yeah, they're like the same thing. So. Is it B in the end? Is it, or it's creating two series again? Like, wives, but to your own husbands, and to your own husbands.
Okay, so the first one is -1 to the n. I think, I don't know what happened, something funny happened. The left one, the series from n equals 1 to infinity of -1 to the n times a sub n. So an nth term times -1 to the n, meaning, hold on, you would start with a negative or a positive on this one. What would you start with?
Negative.
Negative.
Oh,
Negative 1 to the 1. You would start with a negative. This one you would start with a positive. So whether you start with a negative or a positive, that has no bearing. They both can use the exact same alternating series test. Could also have done -1 to the n
That's
plus
your soul. Oh, we better set that.
converge if both of the following are true. So there are two conditions that have to be true. And as you guys notice, the only condition really before getting to those two statements, the only condition is that it needs to be an alternating series. This is a very specific test for a very specific type. The limit as n goes to infinity of a sub n equals 0. We know nothing. Wait. Alternating series. If the limit as n goes to infinity of a sub n is 0, and the n plus first term is always going to be less than or equal to the nth term, regardless of the sign. Look, an alternating series. The a sub n is separate from the sign. Okay? Bless you.
Bless you.
The a sub n and the a sub n plus 1, they're separate from the sign. The nth term is disregarding the sign. So as long as the nth term, disregarding the sign, the limit is 0, as n goes to infinity, and the n plus 1 or n plus first term is less than or equal to the nth term, I can say the series converges. The series will diverge if the limit as n goes to infinity of the nth term is not 0 for an alternating series. Now, wait, we already know that, right? The limit as n goes to infinity isn't 0, well, who cares if it's alternating or not? Nth term test, it diverges. But it's saying if the limit as n goes to infinity, as long as the terms decrease regardless of sign or disregarding the sign, and the nth term goes to 0. Then we're good. Down at the bottom, alternating series will converge if the terms eventually are decreasing. What am I talking about? I'm referring to something we talked about 3 times now. Eventually are decreasing. If it goes up for a little bit, but it'll go down for the rest of the terms, we would just separate. Does that make sense? Just like we've done for other tests. So the test does say decreasing the whole time, but I can separate the bounds and say, okay, well, the first few plus this infinite series, let's test the infinite series. So once again, it's as long as they eventually start decreasing. It may take a while to do so right at the first few terms. So this one, once again, you're going to have those struggles.
You have a snack right now.
Yeah, you have to. This test is pretty nice. It's pretty easy. We just have to make sure that we only use it for alternating. Bye, guys.
Oh, right. Open the door.